Okay, I might have written a little much there. You can see on the answer sheet exactly how they wrote it. The important thing to get from that one is that this right here is the justification. That has to be in there. And you have to have that the derivative changes from positive to negative. Okay, letter C. Now we need an absolute min. So remember, absolute min means you also have to consider the endpoints. And they gave us a closed interval that kind of gave us a hint that we're going to consider the endpoints. So we need to know the lowest point here. So our candidates, possibilities, are going to be g of negative 5. That's one of the endpoints. G of 4. And then another possible min would be where f changes signs, right? Because remember, we're going to go back to here. G prime equals f of x. So g prime, which is the same as f of x, changes from negative to positive. That would be a min, right? When x equals negative, I wrote all over this, it's hard to tell, negative 4. See right here, it's negative and it changes to positive. So if you think about it in terms of this being a derivative, the derivative is 0 here, and it's going from negative to positive, because though this is the graph of f, it's also the graph of g prime. Okay? So we also, basically moral of the story, we also have to consider g of negative 4. So g of negative 5, you can fill in here. And they didn't show work for this. And I think I would, if I were taking the AP exam, I would want to at least write the integral. And if you look at the picture, from here to here are two triangles that are the same area, because they have the same height and the same base. So that's going to zero out. So I think it's okay just to show the formula and then 0. G of 4 would be negative 3 to 4 f of t dt. So now we're going to need to use our area formulas again. So, oh, it's negative 4, wasn't it? That's positive 4 because it's the endpoint. Sorry. This is endpoint. You know, we already figured out from negative 3 to 0 in letter A. So let's use that because we already have the answer. So I'm going to write that it equals the integral from negative 3 to 0. I'm showing my work here. And again, I'm writing this because we already figured this out earlier. Plus 0 to 4. So this one we already know from letter A is 9/2. And then let's see what it is from 0 to 4. I've got a semicircle and two triangles. See my semicircle? Two triangles. These two triangles are going to zero out. Oh, actually, I have to consider that. Okay, wait a minute. I'll come back to that. Oh, yeah, they are, because this goes like this. So here's a triangle here that's going to zero out with a triangle here. So what I'm saying is I don't have to worry about that. What I do need is this. And this gets a little tricky. I'm going to draw it a little bit bigger. It's not actually the area of the half circle. It's this right here and right here. So that's tricky. What that actually is the area of a rectangle minus the half circle, because we want this outside. So we need the area of this rectangle minus this bite that was taken out of it. Okay, so this is going to be 1/2 pi r squared because it's half a circle. And the rectangle, let's see, that would be 2 units wide, 1, 2. How tall is it? 1 unit tall? Oh, that's not so bad. Okay, so this area is going to be the rectangle, which is 2 times 1, minus 1/2 pi r squared. Sorry, I ran out of room. So let's go ahead and write that now. So remember, we had 9 halves for the first half of the integral from 0 to -3, because we found that in letter A. This one is going to be 2 times 1 minus pi, 1/2, because it's half a circle, pi r squared is a radius of 1. And then that last thing is 0, because these two cancel out. And then, I'm not going to simplify this actually. In AP Calc, you don't really have to simplify. Now later, I'm going to have to kind of figure out the value maybe to find out if it's greater than or less than. Remember, we're looking for a min. But let's just leave it like that for a minute. G of -4, this one's interesting. So it would be -3 to -4. Remember, our integral is -3 to x. So we want it to be -3 to -4 of f of t dt. But that's flipped, right? You need your smaller number on the bottom. So that equals -4 to -3 f of t dt. Now we need to look at our picture. And from -4 to -3 is this tall, skinny triangle. If it's 1/2 base times height, the base is 1 and the height is 2. So here we go. It's going to be negative, because we flipped the bounds or the limits. 1/2, base is 1, height is 2, and that's going to get you -1. So, wow, remember why we were doing all this work is we wanted the absolute min. What we did was we tested the 3 candidates, the endpoints, which were -5, +4, and we tested G of -4 because that's where the graph indicated a minimum would be. So which one of these is the smallest? Possibly -1. So -1 is smaller than 0, so this one is out. So which one is smaller here, -1 or this? So here we go, let me ask again. -1 or this. So if you think better in numbers, this would be 4.5 plus 2 minus 1/2 pi. Is that going to be less than -1? No, it's going to be greater than -1. Like half of 3 is about 1.5. So this is going to be a positive number. That's just math in my head. So this is our minimum. And we got this minimum from G of -4. So there's an absolute min at x equals -4. And make sure that, my work got pretty messy because I'm trying to keep it contained on the page so you can see it. Make sure that you clearly have an answer, and make sure that the work that you did to find that answer is especially clear. The other thing, I don't think it's on this scoring guide. Oh, yeah, it is. They really want to see that you identify the endpoints usually as a candidate and that you find that min in the middle. So a lot of times when they ask an absolute min question, they look for both things. And let's do letter D. On this one, they wanted to know the points of inflection. So remember, you find a point of inflection of g of x when g double prime of x changes sign. G double prime of x is going to equal f prime of x. Why? Because remember, g prime of x equals f of x. So it follows that g prime of x equals f prime of x. And and it's when that changes signs. How do we know when f prime of x changes signs? We're going to look at the graph. G prime of x, which is the same as f, g double prime of x, same as f prime of x, changes signs when, I'll just write this for you, you don't have to write this in your answer. When f of x changes from increasing to decreasing, or vice versa. In other words, when it has a max or a min, right? So you may remember that. You may remember that when the first derivative has a max or a min, the second derivative has a 0, and that's a POI. So, for example, if this is the graph of G prime, remember, here it changes from negative to positive, it changes from increasing to decreasing, which means on the second derivative graph, the second derivative would change from positive to negative here, okay, and it has a 0. So this is a point of concavity. So what is that? X equals -3. What's another time if this is the first derivative, when the second derivative would be 0? The second derivative is going to be 0 anytime the first derivative has a max or a min. So here's another place where this graph has a min, so the next graph down would have a 0, and it changes sign, positive to negative as far as the slope goes. So x equals 1 is another possibility. And finally over here, what number is that? 1, 2, 3. At x equals 3. Oops, x equals 2. I just messed one of those up. Let's see. Oh, I'm sorry, I was wrong. It wasn't here. It's here. That's a max, right? So x equals 2. Okay, and again, make sure you clearly box your answers. This one did not ask for any justification. So you can literally just show a little work that leads to your answer. Actually, this one was by visual, so the right answer would get you a lot of points. I hope that's clear, and if you're having trouble remembering the relationship between the function and the first derivative and the second derivative, that's certainly something that you should go back and review in your notes. I think we had a lot of good notes on that first semester.